Hello everyone, welcome to Unit 4, Lesson 1. This unit's going to spend time or 3 lessons doing and solving quadratic equations. It's going to build on something that we did back in Unit 1 where we were factoring quadratic equations. So what we're going to do in these 3 lessons in this unit is solve the equations by factoring, and we're going to look at 2 different forms. We're going to look at the general form, which is in your notes, ax squared plus bx plus c equals 0. And then we're going to look at the standard form where we have an x plus or minus some value squared plus q. And that's their standard form. And I'm going to show you a few examples on how to solve each type. The trick with these is to basically set these equations to 0 and then isolate the x, either by factoring or using some of the methods that we use to solve equations in previous units. The nice thing with all equations is that you can always check your equation by doing substitution. So you should be able to check either by using your calculator or check algebraically by doing a substitution. So we're going to look at 6 examples. Our first example here is 3x squared plus 7x minus 6 equals 0. So back in Unit 1, I would have given you 3x squared plus 7x minus 6 and asked you to factor that. In this unit, all I'm giving you is the same polynomial, but now I'm making it equal to 0, and I'm asking you to solve it, which means find the values of x that makes this statement true. Well, you're going to solve it using the factoring of a type 2 trinomial. So since we have a first term of 3x squared, it can be factored as 3x and x. Now we need 2 numbers that multiply to 6, and then we're going to have to get a middle term that adds to positive 7. So we'll try with 3 and 2. And you can see our cross products will give us 9x and 2x. So if we make the 2 negative, our cross product will give us 9x minus 2x. And we end up with 7x, which matches the polynomial. So we found the factors. 3x minus 2 times x plus 3 equals 0. So that's nothing new. What's new to this unit is now to set each factor to 0. So 3x minus 2 equals 0, and we solve for x. 3x equals 2, x equals 2/3. Set the other factor to 0, x plus 3 equals 0, x equals negative 3. Now what does this mean? Well, if I substituted 2/3 into that original equation, I would prove that the left side and right side equals 0. If I plugged negative 3 into that equation, I would prove left side and right side equals 0. We've done many examples in previous units where we've checked our equations with substitution. You can check these on your own if you wish. Our next example is going to look at one that's in standard form. Example number 2, we have 2n minus 1 squared over 3 equals 27. So this is also a fraction, so we also know how to solve rational equations as well. First thing we would do is multiply the whole equation by 3 to clear the fractions. Then we can go chase the quadratic term. So multiply the whole equation by 3. It'll leave you with 2n minus 1 squared, and 27 times 3 is 81. So since n is only in one single term, what we can do is we can use some of the rules that we talked about in exponential equations to solve for n. If I want to get rid of squared, I could do the inverse operation, which is square root. So if I take the square root of both sides, remember the rules with equations is you can do whatever you want as long as you do it to both sides of the equation. So if I square root both sides, I haven't changed the equation. So the square root of 2n minus 1 squared is 2n minus 1. Square root of 81 has two possible answers, plus n minus 9. So we still can get two answers out of this equation. When I move the 1 to the other side, I could get 2n equals 1 plus 9, which is 10. The other equation would be 2n equal to 1 minus 9, which is negative 8. So you still end up with two equations, but they're a little easier to solve than the example 1 we just did. Divide each equation by 2, and I get n equals 5, and the other one, n equals negative 4. So again, what does this mean? You plug n into the original, either 5 or negative 4, and you would prove that in this case, the left side and right side should equal 27. Remember what you're solving for. What you're solving for are the values of the variable that makes the statement true. Since you have an equal to in the equation, there are only one or two possible solutions to these quadratic equations. For example 3, we're going to look at something a little bit different from the other two examples. Example 3 has x minus 3 times 2x plus 3 equal 5. Now this isn't written in general form because it would be an ax squared plus bx plus c equals 0. This is not written in standard form because we'd have a binomial being squared. So since it's in neither form, what we need to do is get this to one of those two forms. Well, the way that we could do this is to expand the two binomials and then set it equal to 0. So x times 2x will give us 2x squared. X times 3 is going to be 3x. Negative 3 times 2x is minus 6x. And negative 3 times positive 3 is minus 9. And since I have to make this equal to 0, I might as well subtract the 5 from the other side already and set this equation equal to 0. Now simplify by collecting the like terms. 2x squared minus 3x, negative 9 minus 5 will give us minus 14 equals 0. Again, we're left with a type 2 trinomial. My examples, I'm specifically choosing lots of type 2 trinomials because those are always the harder ones to factor. But you could end up with a difference of squares. You could end up with the type 1 trinomials that we discussed back in Unit 1. It's just these are the ones that students have the most difficulty with. So the factors of 2x squared are 2x and x. The factors of 14 could be 7 and 2. So put 7 and 2. Oops, got them backwards. Now we need a cross product that's going to give us negative 3. Well, if we make the 7 negative and we do the cross product, x times negative 7 gives us negative 7x. 2x times 2 gives us plus 4x. When you collect the like terms, you get minus 3x. Matches the middle term. So we now have the factors. 2x minus 7. The other factor, x minus 3, equals 0. Set each factor to 0. 2x minus 7 equals 0, 2x equals 7, x equals 7 halves. X minus 2 equals 0, x equals 2. So there's the two solutions that would make example 3 equal to 5. So when you don't have a quadratic equation in general or standard form, the key will probably be you'll need to do some expanding and simplifying to get it equal to 0, then you're able to solve it. Let's go to another trickier one. Example 4 is going to bring back one of the other things what we used to do with rationals. We've solved rational equations back in Unit 2, but we've had rational equations in Unit 2 solve and simplify to be linear equations. Well, now what we can do is we can make these a little bit more complicated and have a rational equation that'll simplify to a quadratic. So you can see we can get quite a few different types of equations now, and they will always simplify to being linear or quadratic to some of the earlier types of questions we've solved in Units 1, 2, and 3. Again, as soon as you see a rational type, we know that we have to multiply by the common denominator to both sides of the equation. So we'll multiply by x plus 4 times x minus 1. So the first term will be written as x plus 4 times x minus 1. The second term, since I have x plus 4 as a numerator and denominator, they will divide out, leaving me with 2x times x minus 1. On the other side of the equation, the x minus 1's will divide out, leaving me with 3 times x plus 4. Now expand. We have binomials, so we can FOIL. X times x gives us x squared minus x plus 4x minus 4. Plus 2x times x is going to be 2x squared minus 2x. And on the other side of the equation, we get 3x plus 12. So now we can write this in general form. What I'm going to do is just simplify each side first, and then we'll solve. X squared plus 2x squared will give us 3x squared. Negative x plus 4x minus 2x will give us plus x. Minus 4 equals 3x minus 12. Now set to 0, we'll be left here with 3x squared minus 2x minus 16 equals 0. And again, it's another type 2 trinomial. So the factors of 3x squared will be 3x and x. 16, I can try 4 and 4, or I can try 8 and 2. I'm going to try 8 and 2. So I'll use 8 and 2. Check your cross products. I need to end up with negative 16. So I'll get negative 8x plus 6x to give me negative 2x. So it's negative 8x plus 6x, negative 2x. Matches the middle term. So my factored form will be 3x minus 8 times x plus 2 equals 0. I'm going to need to go to the next slide to finish off this solution. So I'll just give you a second or two to catch up and copy the rest of this down. Remember that when you're factoring, you always want to have factors of the first, factors of the last, and those cross products have to add to the middle term when you do that factor chart that we set up. So let me write these factors out again. 3x minus 8 equals 0. The other factor was x plus 2 equals 0. Solve each for x. 3x equals 8. X equals 8/3. X equals -2. There's the two solutions for the rational equation. So in your homework that you're going to get for this, you'll see a lot of straightforward quadratics, either in general or standard form, and then there may be rational or other types of equations that you're going to have to expand and simplify to turn into something that's in general or standard form to be able to factor and solve for x. The last two examples are going to be some word problems. The first one we have here is two consecutive integers, and consecutive means one after another, are added. The square of their sum is 361. What are the integers? Well, we need to define our variables first. So let's let x represent the smaller number. And since they're consecutive, one bigger, so x plus 1, will represent the larger number. So there's our variables defined. Now we create the equation. These two consecutive integers are being added, so we'll go x plus 1, and we're going to square that sum to be equal to 361. Well, we can simplify inside the brackets. X plus 1 can be written as 2x plus 1 squared equals 361. This is written in standard form. So what we can do is we can then take the square root of these, and we can look at this as being, so if we take the square root of both sides of the equation to solve for the x term, the square root of 2x plus 1 squared will be 2x plus 1. The square root of 361 is 19. Plus or minus, there's always two answers when you take the square root of a number. So if we were to solve this, then we get 2x plus 1 equals positive 19, and 2x plus 1 equals negative 19. Solve for x. 2x equals 18. Divide by 2. X equals 9. Solve for x on the other equation. 2x equals negative 20. X equals negative 10. So if you were to look at the sets of integers, x and x plus 1, so x could be equal to 9, or x could be equal to 10. The other one could be, if you were looking at the negative possibilities, x equal to negative 10, and x plus 1 equals negative 9. Now you may be wondering why we have two sets of answers, because when you square a positive or you square a negative, you will get the same result. Squaring the sum of positive 9 and positive 10 would give you the same result as squaring the result of negative 10 and negative 9. So that's why we've got two sets of answers for this question. Again, if you wanted to check, sum these together and square it. 19 positive squared is 361. 19 negative squared is 361. So you're going to see a couple of these consecutive integers, or what we call these number type problems. Define your variables. We tend to always choose the smaller number to be x. Create your equation, solve, either in general or standard form, and then check your answer. Our last example, another very common type, the geometry type questions. So in this one we have a 1 centimeter wide frame is placed around a square photograph. So let's draw the photograph. We're going to put a frame around it. That is 1 centimeter wide. So let's label this. It says the total area of the photograph and frame is 169 centimeters. What are the dimensions of the photograph? So we don't know the dimensions of the photograph, but we do know it's square, so that the length and width are the same value. So we'll let x equal and represent the length and width of the photograph. Now what we have is we have the area of the total frame and photograph. Well, since it's 1 centimeters uniform all around, when you set up your equation, you're going to have to set up including the area of the whole thing. Not just the picture, not just the frame, but the total area. And if you were to look at the outside dimensions, since it's 1 centimeter on both sides, this would be x plus 2 for a length and x plus 2 for a width. Because again, this is a square picture with a 1 centimeter border, which would also be a square frame. So the area would represent x plus 2 times x plus 2, which is x plus 2 squared. We know what that area represents. So 169 equals x plus 2 squared. If we took the square root of 169, we know that plus or minus 13 will be equal to x plus 2. So we can write this now as x plus 2 equals 13 and x plus 2 equals negative 13. Solve for x. X equals 13 subtract 2, which is 11. Or x equals negative 13 minus 2, which will be negative 15. Now this negative answer does not make sense for the type of question, so we can cross that out and say that's one of our extraneous solutions. And now we can look at the dimensions of the photograph as being x, which is 11 centimeters by 11 centimeters. So the dimensions are 11 centimeters by 11 centimeters. And you could do a really quick check. Again, if you had the picture being 11 by 11, you put a 1 centimeter border around the picture. That means you're going to add 2 centimeters to each side. You would end up with 13 times 13, which is what the question says, 169 for an area. Alright, so there's 6 lessons or 6 examples on solving quadratic equations by factoring. A few different types on general form, standard form, and then a couple examples on simplifying an expression first to get in general form or standard form. What I want you to do is work on exercise 4.1. Take care, everyone.